This problem is about reading and interpreting given information, using the fundamental theorem of calculus, and computing an integral using area. At the sea otter exhibit in an ocean aquarium, the flow of water into the otter pool is given by the following graph. In the graph, t equals 0 corresponds to 8 a.m. A. On which time intervals is water flowing out of the pool? B. What is the largest flow rate observed? C. How much did the total volume of water change between 8 a.m. and 6 p.m.? Let's find the key phrases that tell us what's going on. Let's read the problem again. At the sea otter exhibit in an ocean aquarium, the flow of water... Stop. This phrase tells us that we're dealing with a rate of change. The flow of water into the otter pool... Stop. The phrase into the otter pool tells us which direction the flow is going. This will be important with interpreting positive and negative values of flow in the graph. These are the two main phrases that will help us to figure out how to proceed. Flow represents a rate of change. In this problem, it is the rate of change of volume. The word into represents a sign convention. What this says is that when the flow is greater than or equal to 0, the volume increases. For part A, we must find the time intervals when water is flowing out of the pool. The sign convention tells us that we need to find when the flow is negative. Let's go figure that out. We are given a graph of the flow rate. Therefore, all we need to do is look on this picture at where the graph is negative. The flow rate is negative from t equals 4 to t equals 8. Therefore, the answer to part A is from t equals 4 to t equals 8. Or from 12 p.m. to 4 p.m. Remember that t equals 0 was 8 a.m. Part B asks us, what is the largest flow rate? We need to go back and look at the graph to see the highest value of the flow in the picture. We go back and investigate the graph. The highest value we see on the graph is a flow rate of 10,000 gallons per hour. The answer to part B is 10,000 gallons per hour. Part C is the most interesting part of the problem. We are asked to find the total volume change. That is, the volume at time t equals 10 minus the volume at time t equals 0. The key thing to remember is that the flow is the derivative with respect to time of the volume. We want to compute the total change in volume. We are given the flow rate. This is a classic problem relating the total change to the rate of change. The perfect tool for the job is the fundamental theorem of calculus. Basically, the fundamental theorem of calculus says the total change is equal to the integral of the rate of change with respect to time. For our problem, that says the change in the volume will be equal to the integral of the flow from 0 to 10. All that remains is to compute the integral of the flow from t equals 0 to t equals 10. We will do this using the areas of rectangles and triangles in the picture. The first one is the rectangle whose base is between 0 and 3. The second one is the triangle whose base is between 3 and 4. The third one is the triangle whose base is between 4 and 5. The fourth is the rectangle whose base is between 5 and 6. The fifth is the triangle whose base is between 6 and 8. The sixth is the triangle whose base is between 8 and 10. To compute the integral, we need to add up the signed area of these 6 pieces. Pieces 1, 2, and 6 will count with a positive area because they are above the t-axis. Pieces 3, 4, and 5 will count with a negative area because they are below the t-axis. The first area is 3 times 10,000. The second area is 1/2 times 1 times 10,000. The third area is negative 1/2 times 1 times 10,000. The fourth area is negative 1 times 10,000. The fifth area is negative 1/2 times 2 times 10,000. And the sixth area is 1/2 times 2 times 10,000. We need to add all these up to get our answer for our integral. Our final answer for the total change of volume is the integral of the flow, which is 20,000 gallons. Let's do a quick recap. First, we extracted the 2 key phrases, flow and into. The flow is d dt of the volume, that is the rate of change. Into is a sign convention. That means that the volume is increasing when the flow is greater than or equal to 0. Part A asked us when the water was flowing out of the pool. We found the negative values of the flow from the graph. The answer was from t equals 4 to t equals 8, which translates to 12 p.m. to 4 p.m. Part B asked for the largest flow rate. That meant we needed to find the highest value of the graph of the flow. That was 10,000 gallons per hour. Finally, for part C, we needed to compute the total change of the volume. That was the volume at time 10 minus the volume at time 0. The fundamental theorem of calculus tells us that the change in the volume will be equal to the integral of the flow. We computed that to be 20,000 gallons.